Okay, so welcome back, everyone. It's an honor for me to introduce our next plenary speaker, Karen ROEHR-BRACKIN. She is a reader in applied linguistics in the Department of Language and Linguistics and the director of the Center for Research in Language Development throughout the lifespan at the University of Essex. She holds a PhD from Lancaster University and an MA from the University of Hamburg. Her work focuses on explicit and implicit knowledge and learning in instructed acquisition in both adults and children. She is also interested in individual learner differences such as language learning aptitude, cognitive style, learner beliefs, and language learning history. Her most recent projects are concerned with language learning in older adults and the impact of playing to learners' strengths as opposed to compensating for the weaknesses in language instruction. She has published a monograph on metalinguistic awareness in second language learning, as well as a number of articles in international peer-reviewed journals. So, Dr. Karen, the floor is yours.
Thank you. Do I need to switch this on?
Yes, please.
Okay. Right, okay. So I'm going to talk about measuring children's metalinguistic awareness, and this is going to be a theoretical or a conceptual talk. You can't hear me? Oh. Yeah. Just deciding between putting my glasses on or being really far away. Is this better? Okay. Okay, so here is an overview of what I'm going to talk about. I'm going to start with some construct definitions, and then I will briefly review two established theoretical models that allow us to position metalinguistic awareness. And these are Ellen Bialystok's model of analysis and control, and Rod Ellis's notion of explicit L2 knowledge. I will then review some selected measures of metalinguistic awareness that have been used in existing research. I will provide some examples and critique these. And then I will propose an updated theoretical model that allows us to map concepts and tasks that are relevant to L2 or additional language learning. And in this model, knowledge representations are characterized in terms of how implicit or explicit they are, and also in terms of how specific or schematic they are. And then I have a very brief conclusion. Okay, so starting with construct definitions. Metalinguistic knowledge, in the sense of knowledge about language, is part of a learner's explicit knowledge. And explicit knowledge and learning typically draw on a learner's metalinguistic awareness, in the sense of their awareness of the nature, function, and form of language. Put differently, we can say that metalinguistic knowledge or ability refers to any objectification of language, in the sense that it is characterized by attention to language form rather than linguistic content or meaning. Or to quote Cummins back from the 1980s, it is looking at language rather than through it to the intended meaning. And you may have already noticed that I'm slightly switching between terms here. Metalinguistic keeps occurring, but we have metalinguistic awareness, metalinguistic knowledge, metalinguistic ability. So I won't attempt to distinguish these. I will treat them as equivalents. Researchers often do, although there is an attempt from Ellen Bialystok to try and separate them theoretically, but for practical purposes, I think we can treat them as more or less as synonyms. So this is what I'll be doing. A metalinguistic knowledge, ability, awareness is a higher order skill, and there's quite a lot of evidence that it is related to general cognitive development. Depending on how exactly we define it, it typically starts to develop around ages 4 to 7. And what is uncontroversial, I think, is that as children get older, they increasingly attend to and manipulate language forms. Metalinguistic awareness has been shown to be related to literacy, and indeed basic literacy skills may be a prerequisite for children, people developing metalinguistic awareness and knowledge. And we have evidence from illiterate adults that if you cannot read or write, it is very difficult to treat language as an object that is accessible to analysis or reflection. So illiterate adults, although they are cognitively mature, often treat language as a means of communication only, similar in that sense to preschool children. Metalinguistic awareness has also been shown to be related to bi- or multilingualism, in particular bi- or multilingualism from birth, which seems to enhance metalinguistic ability at an early age. So in these studies, comparisons were made with monolingual children, and although, of course, monolingual children can develop metalinguistic skills as well, typically, bi- or multilingual children develop the same skills a little bit earlier. So it's a matter of a quantitative difference rather than a qualitative difference. Metalinguistic awareness is also related to L2 achievement in instructed settings. The argument is that it helps with L2 learning, but it seems to be a bidirectional relationship, really. So we can also argue and perhaps see that through L2 learning, children enhance their metalinguistic awareness. So it's, in a way, an upward cycle. We also have a partial overlap between metalinguistic awareness and language learning aptitude, in particular in the area of language analytic ability, which is part of language learning aptitude, but also is implemented in certain tests of metalinguistic awareness. And of course, in theoretical terms, this overlap then would explain any predictive power of metalinguistic awareness, because aptitude, of course, is supposed to predict L2 achievement, and if we overlap, if there's an overlap with MLA, then yes, that would also predict L2 achievement. Okay, so those were the definitions. Let us now look at two theoretical models that allow us to position metalinguistic awareness. Here are the two models I would like to look at side by side. The first one is Bialystok's classic model, where she discusses analysis of knowledge and control of processing. And this is actually intended to be much more general, a model of cognitive development, no less. And this, for her, includes language development and, of course, also then metalinguistic development. She is or was primarily concerned with bilingualism from birth or child learners, and she essentially takes an L1 perspective. This can be contrasted with Rod Ellis's view of explicit knowledge or metalinguistic awareness as a part of explicit knowledge. He contrasts this with implicit knowledge, and he very much takes an L2 perspective, and his focus is on instructed L2 learning and actually cognitively mature learners, adults or adolescents. So his work really is a model of language or L2 knowledge. So looking a little bit more first at Bialystok, the first component of her framework is analysis of knowledge, and she argues that as we get older, as we develop, our knowledge representations become increasingly analyzed. And by that she means they become more complex, more structured, and more abstract. So in that sense, implicit knowledge gradually becomes more explicit, and through that it becomes more accessible to consciousness. So this is an example taken from her work in the 1990s. So at early stages of development, we have conceptual representations where we might have meaning-based associations, for example, between a dog and bone. As we develop further, we also build up formal representations. So now we are building hierarchies, we have a taxonomy, and we might then additionally associate dog and cat by means of their common category of pet or animal. And as we develop further, we add symbolic representations. For example, we can have a hierarchy and associations based on word class, such as cat, dog, bone, or nouns. The second element in her model, control, refers to procedures for accessing our knowledge representations. At the time, in the 1980s, she called it control of processing. I think in the meantime, most people nowadays would refer to this as what we call executive function in studies on working memory, for example. So as we develop, as we mature cognitively, we get better at allocating attention to relevant aspects of a knowledge representation. We get better at inhibiting irrelevant information, and we get better at monitoring and switching. So all of these are components of executive function. This is taken from one of the earliest publications where Bialystok and Ryan talk about this framework. And you can see that it is conceptualized as underlying cognitive development and language development in one go. So we have two axes here, an analysis on the horizontal axis and control on the vertical axis. And you can see that metalinguistic skills are in the top right quadrants, so requiring high analysis of knowledge and high or strong control of processing, so really higher order skills. Literacy in the middle, and then informal conversation as low analysis and low control. Yes, so I've already said this. So basically, highly analyzed knowledge refers to then very structured, very abstract representations, and that means we can actually retrieve details independently of context. So in that sense, explicit. And control, likewise, so in order to perform metalinguistic tasks, we need to be able to focus on some types of information, for example, form, at the exclusion of others, for example, meaning. So looking through meaning at the form deliberately. So this is why we require high control. Let us now have a few minutes on Rod Ellis's framework. Rod Ellis defines explicit knowledge as the conscious awareness of what a language or languages in general consist of and or of the roles that it plays in human life. Explicit knowledge is knowledge about language and about the uses to which language can be put. So a very general definition, and then he elaborates on this definition in his detailed 2004 review paper of explicit knowledge by listing characteristics of explicit knowledge. For Ellis, explicit knowledge is conscious by definition. So this does not necessarily apply to Bialystok's model. So Ellis says that there is a difference between, for example, recognizing that a sentence is ungrammatical and cognizing why a sentence is ungrammatical. So just recognizing an ungrammaticality he would call intuitive awareness, but being able to say why it is ungrammatical is conscious awareness. So this is explicit in his definition. Explicit knowledge is also declarative in Ellis's model. In other words, it includes facts about language. For example, that we have verbs and nouns in a language. As he is focused on learners, he also lists the characteristic of imprecision or inaccuracy. So learners are not necessarily trained linguists. So he argues that their explicit knowledge may not be perfect, it may be flawed, they may have grammar rules, in quotation marks, pedagogical grammar rules that are quite useful, but not maybe linguistically precise if we are a descriptive linguist, for example. Again, with the focus on learning, explicit knowledge is developing. It grows as we go through our L2 learning progress. It can get broader as we accumulate more facts about language, whether through lessons or working them out ourselves. It can also become deeper as our existing explicit knowledge is refined and as we get better at applying it more consistently. Explicit knowledge is accessed through controlled processing, so staying with this declarative procedural distinction, and views whether it can be automatized or proceduralized differ. So I won't go into this any further, but there has been some recent movement on this point, I think. Learners use their explicit knowledge as a support mechanism, so we can use it to resolve difficulties we might have with the L2. So, for example, if we don't comprehend as we wish, we can try to analyze the input. We can use explicit knowledge to enhance our productive L2 use, for example, to monitor what we write and to try and improve it by applying explicit metalinguistic knowledge. Explicit knowledge in Ellis's framework can be verbalized, memory permitting, and cognitive maturity permitting. A learner can talk about their explicit knowledge, articulate it. And finally, explicit knowledge is learnable. Any learner can acquire explicit knowledge to some extent, but of course there are individual differences, and we also need to take age into consideration. So if we look at the two models again side by side, I think a key point is that in Bialystok's model of analysis and control, there is an assumed progress or movement from implicit, where children start out, towards more explicit. Whereas in Rod Ellis's model, the assumption, although it's tacit, I suppose, I don't think he says this explicitly anywhere, the movement or the progress is in the opposite direction. So he assumes, understandably, because he works with adults, with instructed adults, we start with explicit information, and then as we progress, as we get more proficient, hopefully we build implicit knowledge. So the movement is in the opposite direction. Okay, is this okay so far? Or do you have any questions? I'm happy to take questions as I go along. Okay, so next I'm going to look at some selected measures of metalinguistic awareness that have been used in existing research, and then I'm going to comment on these. First of all, broadly speaking, we can distinguish between quantitative and qualitative measures. In the first category of quantitative measures, we have theoretically derived tasks that are actually based on the classic model of analysis and control, mainly from Bialystok's team, but also other researchers. We also more recently have executive function tasks, so reflecting the update, I guess, to the control component, that draw on more updated conceptualizations of executive control as a component of working memory. We also have theoretically derived tasks that are based on Rod Ellis's model, so the idea of explicit L2 knowledge. And then we have a third category of tasks, which I have labeled here empirically derived tasks. So those are not informed by a single theoretical framework, but they maybe draw on both or all the available theoretical apparatus we have available. So I'm going to have one example from each of these. I won't go into qualitative measures for practical reasons. So qualitative measures typically are some kind of verbal protocol that is then analyzed for evidence of metalinguistic awareness. And of course, this differs by study, case by case. So we may have interviews, we may have think-aloud protocols, we may have retrospective protocols, again, also depending on the age of the learners. Okay, so tasks that require the learner to detect, extract, or articulate linguistic properties or structures have been used to try and access analysis of knowledge. And here I'm listing some examples. For instance, making learners correct errors, making learners define concepts explicitly, for example, asking them, what is a word? Judging concepts, asking them, is X a word? Recognition of ambiguity in any language, including the L1. Acceptability judgments that are focused on grammaticality. And verbal fluency tasks that use the category condition. So that would be something like name as many animals as you can in 1 minute. Any tasks that involve misleading cues or that ask the learner to focus away from meaning have been used to access control of processing. So here, in order to resolve the task, the learner has to select and integrate the right kind of information. Tasks in this category are Piaget's classic sun-moon problem, where we basically play on the arbitrariness of language and where we ask the learner to make a clear differentiation between the word on the one hand and the referent on the other hand. Another task, which I personally find very, very strange, is to make learners repeat deviant sentences. So they have to repeat the error and stop themselves from correcting it. Acceptability judgments that are focused on semantic anomalies. And verbal fluency tasks in the letter condition. So this would be something like name as many words starting with the letter P in 1 minute. To illustrate this, I have taken here a task from a very old study by Bialystok, 1988. So she had acceptability judgments with children, and these judgments came in 4 different conditions. So the first condition, everything is fine. So, for example, a sentence like apples grow on trees, or why is the dog barking so loudly? No problem. So this is like a control condition almost. In the second condition, we have sentences that are grammatically incorrect, but semantically okay. So apples on trees grow, and why the dog is barking so loudly. So she argues that in order to deal with these sentences in the second condition, we need high levels of analysis so we can detect the ungrammaticality. In the third condition, it's the other way around. We have sentences that are grammatically correct, but semantically odd. Apples grow on noses, and why is the cat barking so loudly? So here she argues we need good control of processing to inhibit the influence of the semantic oddness or anomaly. And then in the fourth condition, everything is wrong. So again, it's sort of maybe not so challenging because you have many indicators that there is a problem. Apples on noses grow, and why the cat is barking so loudly. So theoretically, at first glance, this looks neat and tidy, but really, on second thoughts, perhaps both the second and the third condition require both analysis and control. Because in practice, to me at least, it is not always that obvious on how you can differentiate these two components. Because a focus on form is actually the natural consequence of a focus away from meaning. And the one is the operationalization of analysis, the other, the operationalization of control. So can we really separate these two dimensions empirically? Okay, now we come to the updated version of control, if you like, so executive function tasks that have been widely used in more recent research. These tasks directly aimed at assessing selective attention, inhibition, monitoring, and switching, so all the components of executive control. Examples are the dimensional change card sort task, which is maybe the least known, so I will illustrate that in a moment. Stroop task, Simon task, flanker task, these last 3 widely used, also with adults, and perhaps better known. But if you want me to illustrate or explain later, I can do that as well. Let us look at the dimensional change card sort task, again from Bialystok. So in this task, basically, it does what it says. The label is quite accurate. Children are required to sort cards by one dimension that is given. Usually it's presented as a game. And then after they've played this game for a while, they are given a new rule to play the game, and then they have to resort by a different dimension. So in this particular example here, we have blue squares and red circles as the stimuli. And children are told, okay, in this game, you need to put all blue pictures in the box with the blue picture and all red pictures in the box with the red picture. Meaning, of course, then, that the blue square, for example, would go in the box with the blue circle. So we are sorting by color. And even very young children don't have a problem with this. So this is the baseline, basically, and I would say probably even 4, 5-year-olds, no problem. So they do this for a while, and then the interesting part of the task begins, which is the switching. So now children are told, we have a new rule for this game now. Stop what you're doing, and now you have to put squares in the box with a square and circles in the box with a circle. So the dimension by which they sort is changed. So now our blue square goes into a different box. It goes into the box with the red square, because now we are no longer sorting by color, but we are sorting by shape. And this is then where, in very young children, differences have been found between bilingual and monolingual children, where bilingual children are typically better able to do this at an earlier age. Monolinguals, of course, catch up, and for adults this doesn't work, it's too easy, but with very young children it can work. So the problem with this is, yes, it's a great executive function task, but most or almost all executive function tasks are non-linguistic. They measure fundamental cognitive capacities that underlie higher order cognitive and linguistic abilities. So yes, we measure executive function, but of course, as we have said, metalinguistic awareness is more than this. It will imply executive function and draw on executive function, but it's something else in addition, or something more. So these tasks arguably then cannot directly assess metalinguistic awareness. Tasks measuring explicit L2 knowledge based on Rod Ellis's conceptualization typically require learners to apply or articulate explicit knowledge about the L2. We have metalinguistic labeling tasks, where we ask learners to label language. Is this a verb? Is this a noun? And of course, you can turn it around, as we saw in the presentation before the coffee break. So you can provide the labels and say, apply those. Error correction, description, and explanation tasks have been used quite widely. So there essentially, learners apply pedagogical grammar rules to sentences. And this can also be turned around, so we may ask them to exemplify pedagogical grammar rules. So we provide a rule and say, okay, write a sentence in the L2 that illustrates this rule accurately. To give an example from a study one of my students did some time ago, so a classic error correction and explanation task. So a sentence is provided that contains a mistake. The mistake is already highlighted, and the correction really is of lesser interest because, as we said, we can correct based on intuitive awareness, but because correction seems a natural step before you explain, we usually put this in, and then what is actually scored for metalinguistic awareness is the explanation. So can students articulate why they made the correction? A potential issue with this type of task is that it depends on age. If you have younger children, it just doesn't work. Younger children are still developing their literacy skills, so providing these written tasks is not so great. They might not necessarily be so articulate when it comes to explaining, and they may also lack meta-language. So with 11, 12-year-olds, this might well work. With 8-year-olds, not so much. Okay, this brings us to the last category, which are the empirically derived tasks. These typically cover multiple linguistic domains, so not just grammar. And really, these tasks were designed or are designed with a focus on what works in a particular context. So what is the setting, what is the age range you want to test, and what are the language combinations? So here are some examples. This is from Angela Tellier's work, one of my former PhD students. This is from a test of metalinguistic awareness for English-speaking children who did not know these languages necessarily, ages 8 to 11. Can you do it? I think you can. Another one. Again, they did not necessarily know these languages. In fact, they didn't, mostly. And another example from the same test. So the first part of the test is based on natural languages, as you saw in the first two tasks. And the second part of the test draws on an invented language, which of course none of the children know because just made it up. And I'm sure you can work it out. What is the answer? Test. 1, 2, 3, or 4? 2. Okay. This is from an ongoing project in Norway. So the instructions are in Norwegian. You can now draw on our cross-linguistic awareness if you know any Germanic languages. So it says, which word, this is my using German to translate Norwegian, which word ends with the same sound as the word in the square, draw a line. Okay. Circle the longest word. So this is word referent differentiation, right? So you're not influenced by the size of the object, but just focus on the label. And I actually don't know the Norwegian ones, so it's definitely not the plane, I'm sure. And they also, in this test, used an invented language. They call it monster speak. So they provide examples with Norwegian translations. And based on those, children are asked to work out the monster speak and translate the Norwegian sentence into monster speak. So language analytic ability, right? And here, drawing on the L1, same test. Draw a line between the words in the sentence, so everything's been clustered together. Yeah, separate the sentence into words. Okay, so potential issues with this type of task. Well, I guess the advantage of this type of task or test is the same as the disadvantage. Context dependency. So if it's for your context, great, you've got exactly the right test, but that's it. So this Norwegian test, for example, you cannot use it outside Norway because you need Norwegian speakers for that. So it's dependent on the L1, dependent on the particular age range it was designed for, the level of education, and the kind of input the students have. And of course, we can say, well, this is arguably theoretically untidy, because these tests do not operationalize a specific model of metalinguistic awareness. Until now, so this is very daring. So I'm now going to suggest an updated model that may help us map concepts and tasks that are relevant to the L2. And in a way, I am using both Bialystok and Ellis in combination. So what I'm proposing is to have, like Bialystok, 2 axes, but these axes are labeled differently, and above all, development can go in both directions. So on the horizontal axis, we have implicit and explicit, going in both directions, hence the arrows pointing in both ways. And on the vertical axis, we have specific or item-based knowledge representations, for example, individual sounds, specific words, or also if we go beyond individual units, it could be memorized chunks, but they are concrete, specific instances of language. At the other end of the scale, we have schematic or abstract representations, so any kind of patterns or rules. So I've put rules in quotation marks. This depends on your theoretical outlook, if you think they are psychologically real or just metalinguistic tools. So basically then, the knowledge representations that we acquire during L2 learning and that we access during L2 use are or can be located, hopefully, on these axes. And yes, as I've said, so the horizontal axis, we are talking about representations and learning as either more or less implicit or more or less explicit. So you can see here that unlike Bialystok, I'm combining representation and learnings and access, if you like. So process and stored knowledge are combined. The same for the vertical axis, so representations and learning can be more or less item-based or more or less schematic. So what I've tried to do then is take relevant constructs that we've defined in the first part, and I have taken tasks that appear in the literature to measure these constructs, and I've tried to place them on my figure. And you are invited to take issue with this or to do this differently or critique it. First of all, here I have taken some tasks that measure metalinguistic awareness, some of which we have discussed, some we haven't. And I have tried to place them on my graph. So, for example, we have verbal fluency tasks, word referent differentiation, segmenting sentences into words in the top right-hand quadrant. So specific, item-based, concrete language, but explicit. We have error explanation, trying to work out patterns, so using an artificial language, for example, in the bottom right-hand quadrant. Explicit, but schematic, so drawing on abstract patterns. And then I have some sort of in the middle, executive function tasks, acceptability judgments. But there was nothing I wanted to place on the left-hand side, and indeed this is how it should be, because we have defined metalinguistic awareness as objectification, explicit, etc. So by rights, our tasks should be on the right-hand side. Next, I have taken tasks measuring language learning aptitude. Remember, I have mentioned a partial overlap, and in particular on the issue of language analytic ability, which is part of metalinguistic awareness, but also part of typical language learning aptitude measures. So here I have taken the LAMA aptitude test. I have only put the not very informative labels. So LAMA-B measures essentially vocabulary learning ability, sound meaning, form meaning association, learning new words. LAMA-E is sound symbol association. LAMA-F is language analytic ability, inferencing grammatical patterns. Working memory tasks are also used in aptitude studies. So again, they are sort of in the middle, executive working memory, phonological short-term memory moved slightly across. And most recently and importantly, we now also have tasks that are supposedly not so well evidenced, but we're getting there, supposedly measuring aptitude for implicit learning. So this is much newer, and this is why we can now place some tasks on the implicit side of the graph. And indeed we should. So if we want to predict, aptitude is supposed to predict L2 success, L2 achievement. If we want to predict all of L2 achievement, we need aptitude measures that tap aptitude for explicit learning, but also aptitude for implicit learning. So the proposed tasks are serial reaction time and priming tasks, not much research, but there we are. Okay. Tasks measuring L1 literacy. We have seen that L1 literacy is related to metalinguistic awareness. And here are some literacy tasks, which again, all appear on the right-hand side, on the explicit side, which makes sense, I guess, because literacy is so closely tied to metalinguistic ability and is essentially explicit. And finally, tasks measuring L2 proficiency. So now it's getting very rough. I've only done 5 squares because there are so many possible tasks. So I've sort of separated it a little bit by skill, reading, writing on the explicit side, oral tasks, and response time measures on the implicit side, and elicited imitation. I couldn't quite decide because that's subject to debate. What does it really measure? So I put it in the middle. But I think you can see how this works. So the idea is to use the graph really just to try and help us think, help us conceptualize, and maybe for practical purposes, when we want to use tasks in a study, to see, do we need to cover all 4 quadrants? Do we have a lot of overlap? Do we need to use If we have 3 tasks that are all overlapping in the same corner, do we need them all, or should we spread further? So, advantages, potentially, we can place different types of linguistic and non-linguistic tasks in relation to each other. And hopefully we can capture both knowledge, so representations, and learning or use, so the process, in one go. We can maybe visually or more easily identify and conceptualize points of difference and points of overlap, such as I've tried to demonstrate. So I'm not saying that this is in any way a theory, it's really just a thinking tool. The other important point for me is the bidirectionality, which allows for development in either direction. And I think recent research has evidenced this quite strongly. So we can start with implicit knowledge, or we can start with explicit knowledge. So I'm assuming an interface between the two. And more recently, researchers have argued for automatized explicit knowledge. So again, we can accommodate this on this scale. And we can learn bottom up. We can start with items, with chunks, also as adults, and analyze these maybe later. Or we can start top down, especially as adults. We can start with patterns, with rules, and then fit things into the slot. So again, interface assumed both ways. So in that sense, as I've already indicated, it's a combination of Bialystok's and Ellis's model. Analysis and control are combined, whereas Bialystok really wanted to separate the two. So in my model, the two are in one. So we can, I think, conclude from existing research that if we have explicit knowledge, we can assume more effortful, more controlled access. So knowledge and access or use go together. Finally, bidirectionality, I've said it as well. So this was really important to me because I found the analysis and control model useful, but it was one way, and the Ellis model useful, but just the other way. So I would like to emphasize both directions, as I've already said. Okay, and potential issues with everything. So already, I've just come up with it. There are issues. We only have 2 dimensions. It's two-dimensional display. We might want to think about other dimensions. For example, modality. Is it visual or is it auditory? We might want to have a better differentiation by the nature of stimuli, linguistic versus non-linguistic. And I'm sure you can come up with more issues if you start thinking about it. And finally, just one slide for conclusion, very quickly. So, yes, so this was very conceptual, theoretical. Of course, any refinement of the conceptualization should go hand in hand with refinements of operationalization, so how we actually measure. And an interesting new development, just one example, is the opt-out task that has been used as a measure of access awareness in young children, where a behavioral response is used to assess awareness. This is the youngest group. From 4 years onwards, this already works. And of course, we might want to argue for more comprehensive measurement. Maybe we should try to have some overlapping measurements to assess validity in our studies. But as ever, practicality is an issue. There's only so much we can make our participants do. Right, thank you. Finished.
Okay, so now we have a few minutes to answer questions from the audience. Yes.
Is it working? Okay. Yeah, thank you, Professor ROEHR-BRACKIN. I didn't know you were an alumni from Lancaster, like I am.
Oh, okay.
So we have something in common, also on the topic. I just wanted to ask you. So within the quadrant, I know that you said this is it's a kind of new combination of theory, and I think this is what we need in the field. We need more theory. If you think about the 80s, probably the 90s, there were a lot of theories, including the attention, what's it called, Schmidt and so on. And nowadays we're more applied, so we're basically as researchers in the field. So I think there is a lot of potential for future research. But I also want to ask you about the attitude-treatment interaction within the because you said they are overlapping, but there might be also something that we need to explore is this interaction between cognitive abilities or individual differences, if you will. But here I will refer to cognitive abilities because this is what we are talking about. So where do you think this interaction would fit, if would fit? I think it will within the model.
The interaction between cognitive abilities, so the individual learner differences, and then different types of treatment.
And yeah, and on the other hand, developing the type of knowledge as well, right? Well, I mean, we do have so implicit instruction should lead to some kind of implicit, but that's hard to do. However, I think probably some of the failures to find effects in treatments is because we don't consider this interaction. And this is not my idea. This is an idea that Kaiser has been saying for a while. We need to look at these interactions.
Absolutely. I could give a very long answer now, but in fact, this is what we're working on at the moment. Kevin actually took part in our pilot study for this last year. So this is very, I think, very important and not really that well researched. We have a long tradition of aptitude treatment interaction studies going back to the early 80s, but they are so diverse and so different in setup, in research design. It's very difficult to compare. So I think one issue that we have discovered in our most recent study, which we're just beginning to analyze, is that we have, and traditionally we assume linear relationships, and we have done this. So if we don't find a linear relationship, we say there's nothing there. And what now the very latest, including Izuka and Dekeza 23, just out, and something one of my collaborators, my PhD students, has found, and this in a way has inspired this whole thing actually, is that if different aptitudes can pull in different directions, and we had never really considered that. So aptitude, we think ability, meaning black and white, the more the better, right? The more aptitude, great, fantastic. But now with this explicit and implicit, actually it seems to be the case that explicit aptitude pushes you in one direction and helps with one kind of learning, and implicit aptitude can have the opposite effect. So in this study, Izuka and Dekeza, and then my student study, we have a negative prediction from implicit aptitude and a positive prediction from explicit aptitude for grammar and reading in L2. So this is something that has not been found before. And I think the other possibility, and we haven't got there yet, is that so we have different treatment modalities in our study: auditory input only, written input only, mixed input. And in some groups, we have the expected pattern, higher aptitude, better performance, so linear, nice and linear. In one of the groups, we do not have this. But does this mean aptitude doesn't matter? Or does it actually mean there is a nonlinear relationship? And that would make sense in an aptitude treatment interaction approach. Because you could say, okay, if you have high aptitude and let's say it's auditory input and you have high phonetic coding ability, so would you benefit from this auditory input? Then we would get a linear relationship. And if you have low phonetic coding, you don't benefit from it, it's all too much. Yeah, so linear. But what if, as you get more auditory input and you have sort of medium phonetic coding, is that compensating for your weaknesses, and does that give you the boost? And this is actually what we are now looking at. It might well be, because it is hence the example, our auditory group, where we do not have the linear relationship we have in the other groups. And just before I came, we were making graphs and quadratic lines, and it might well be that it's not like this, but it's like this. And you don't see a correlation, but you still have something there. You just need the right analytic tool we are just trying to identify. So, sorry, long answer. There's a lot to say. Shut up.
The looking at quadratic and all that. And there is this book by Mirment to look at orthogonal contrast. So that's one way to encode this quadratic and this linear in one analysis. I can give you later it already has the script in R, so you just need to adapt it. So I can give you.
So the GAMs, is it a GAM?
No, GAMs are complicated because even though they give you the nonlinear, it's hard to understand and to interpret. But the quadratic is quadratic, and even the other terms might be simpler to interpret, like as you said. So what I'm saying is one way to do it is using these orthogonal contrasts in the code.
Okay.
So different contrasts, basically. Mm-hmm. Okay?
Thank you.
Thank you.
Thank you very much. It was very interesting. I just was wondering very quickly. What I liked most about your presentation is that you have finally put implicit and explicit learning both on the same place and interacting. But what if implicit and explicit learning would be like two triangles that go, one is going less and the other one is growing? I mean, starting with implicit learning, and that will take explicit learning higher. So it depends on how long have you been learning a language. Maybe you are using both implicit and explicit learning at the same time, but in different degrees, depending on how you are learning. But I am not, what I think that is very positive is that we are not putting them opposites, but complementary.
Yes, and I think this is what's happening. We are using both to different extents, and of course it also depends what we test, right? So which part of language? So yeah, absolutely. Yeah.
Any other question from the audience? Okay, so in that case, I would like to ask one. I would like to go back to a similar question than his. So I'm going to ask about treatments. Because in classes, what we often find is a mixed ability class, where some people have higher learning aptitude or higher metalinguistic awareness, and some other children have less of that. So maybe would you think that one treatment could benefit all of them? Or we would need to take into consideration that individual difference?
Yes. So yes,
it's a hard question, I know.
Yes. So again, not a simple answer. I mean, when I reviewed the aptitude treatment interaction literature, what seemed to be a common trend, and also something we have found, is that if something is familiar, you can level out individual differences to some extent. So familiarity could be the type of instruction they are used to, so classic sort of maybe PPP, kappa, whatever, so that if that's what they're used to. Another familiarity aspect could be proficiency, or experience. If learners are quite experienced, they've already learned 5 languages. Again, individual differences seem to be leveled out. So what I can see maybe very globally is that you would get the strongest effects of individual differences at beginner level and where learners are less experienced. So in such a scenario, then to have something that fits everyone, I'm not sure actually. On the other hand, how can you accommodate everybody's particular profile? So if we found in aptitude treatment interaction research that we can actually compensate for weaknesses, we might, judiciously try to do that as well. But yeah, it's a very good question. So in that sense, there's a gap between the very practical concerns and the research. Yeah, so no simple answer, I'm afraid.
I think the model that you presented is very good to have an overview of the... Oh, sorry. Yes, we have a question here.
I would like to tie in with your question, actually, and I'm maybe going to make it even harder for you now to answer.
No, that's good.
But you say, is there a method that would benefit all children or all learners? And considering the aptitude treatment interaction literature that is there, I think it's very complex, and you mentioned it before, it's a patchwork, it's very difficult. Nevertheless, I'd like to ask this, is it worth the while? Because if you look at the results from these intervention studies, sometimes you see that there maybe is like a 1-point difference in a proficiency test at the end, or there are such slight differences that maybe come out as statistically significant. But my question is always, how does that actually transfer into the classroom? And how can you actually apply these results? You know?
So you mean, is the aptitude treatment interaction research worthwhile?
No, well, I think it's worthwhile, but how do you actually apply it in the classroom? Is it transferable to classroom practice?
Hopefully, eventually, but I guess it depends on the level of detail you're talking about. So if you're saying, okay, I have this particular group of 25 11-year-old Swiss children who, I think at that level, nobody can realistically say, okay, I have the solution for you. But maybe at a broader level, if we can understand, for example, at what point, if we look for the tipping point, at what point do individual differences level out? Because they do. I mean, we do have this evidence, for example, the working memory research. The first assumption is, the more working memory, the better for your L2 learning, but it's so broad. And you do get effects of working memory in early stages of vocabulary learning, for example. But if you take more advanced learners, my students do it all the time, I want to look at working memory and L2 proficiency. They take advanced English learners, no relationship. They've gone past it. It doesn't matter anymore. They have their vocabulary store, and now we are at a higher level. So if we can maybe identify a point where the leveling out happens, I think that might be worthwhile, potentially. If we can find strong evidence that we can compensate for weaknesses meaningfully and improve proficiency, I guess this is interesting, because I think typically the studies that did not just measure cognitive ability and outcomes, but also included learners' own perceptions, preferences, views, find that if you play to learners' strengths, they like it better. But maybe if we find that we need to compensate for weaknesses and we can do this successfully, then this is helpful, because we might want to give them something they don't like so much, but we know it's good for them, But it is broad, I admit that. So telling a teacher, do this in your specific classroom, no, we can't yet.
And I think you brought in another element there. I mean, we talk a lot about proficiency and trying to get the most, the highest level of proficiency. But if we talk about young learners, there's always much more at play, the self-esteem and the well-being. And you said, do they enjoy what they're doing?
So everything needs to come together eventually, but I don't think we're there yet, actually. Despite decades of this. Thank you.
So I'm afraid we have run out of time for more questions, but I think you'll be glad to know that it's time to have lunch. So for those of you, thank you very much for your time.